Hello, everyone. So let me start with a question. Why am I starting the data structure series with heaps? So while I was preparing for the interviews, somebody asked me the question of finding the kth largest element. And I gave the approach of sorting all the elements and then finding the kth element, which is very stupid now, I know. But at that moment, I realized I knew heaps from the data structure classes and data structure lectures. I knew it was used to find the largest element, the smallest element in O1 complexity. That is the constant time complexity. But still, I couldn't implement that question using heaps. And then I realized that some of the data structures were taught well in our DSA classes, but we still do not know the implementation part. And I know this is not the case with most of you. Most of you might be very smart to just implement it out of everything. But still, I wanted to start with heaps because of the given reason. So yeah, let's start with heaps. So yeah, if I am to tell you how is this going to approach ahead, I'm going to start with brief introduction on heaps that will only consist of the heap part that will be helpful in solving the questions. And then we'll be going to the two types of heaps we have, min heap, max heap. Then we'll be solving the list of questions from a NeetCode sheet and from the Striver's SDE sheet. We'll solve all the problems and then heap as a data structure. This part is going to consider of all your, insertion, your deletion, heapify, heap sort, everything else, right? So we'll be taking this one by one as we go ahead. Now, what is heap? Let me start with, okay. Let me start with what is heap. So what is heap? Heap is a complete binary tree. What is a complete binary tree? Complete binary tree that follows your heap property. These are the 2 points that we need to understand. Okay. So what is your complete binary tree? A complete binary tree is a binary tree that is all its, levels filled up, except the last one. And the last one is not that it has to be unfilled. It can be unfilled, right? But if it is unfilled, it has to be filled from left to right. Okay, this is your complete binary tree's definition. What is heap property? One second. Yeah. Let me start with what is my heap property. Heap property says that the heaps have to follow a heap property. Okay, but what is heap property? Heap property says that we should be able to get the largest or the smallest element at the top of the heap. Let us consider this as my heap. Okay. This element, if this is the max heap, this should be the maximum element. And if this is my min heap, then the top of the heap, this element should be my minimum element. What do I mean when I say minimum element? The all other elements can be equal to or greater than this element, right? And when I talk about the maximum element, all the other elements in the heap can be lesser than or equal to this element. Completely everybody on the same page? Yeah. So this is my min heap, this is my max heap. Now just a quick example on this part. Let's say I have the 2, 7, 9, 5 and 10 as example. Now if this is max heap, what should be I getting on the top of the heap? I should be getting 10. If you ask me, are all other elements, is everything arranged in a sorted order? No, it is not. But yeah, right now we're not concerned with it. Right now we know that if I have to find the element, we get the minimum and the maximum element in the constant time complexity. Constant time complexity, that is O of 1. Everybody on the same page? Great. Yeah. Now let me go to what is max heap and min heap. So in C++, we have priority queues. And on the basis of priority queues, we find our max element and our min element, right? So what is the syntax? Now this is the column for, let's say, okay, this is where we are going to talk about our syntax. So when it's the max heap, and it is done through priority queues. How? What do you write? This is the syntax. Everybody, please see it properly. Priority queue, angular bracket end, max heap. This is the variable name, and you can give any name to it. You can just give it PQ, you can give it any name, but try giving meaningful names. That will help you in the longer run while you're sitting for your interviews and everything, interview placements and everything. Try giving very meaningful names to your variables. Then coming to, let's say, min heap. What is the syntax for min heap? Here we're just going to use the comparator difference, priority queue, int, vector, int, greater, int, min heap. Again, this is your variable. You can give it any name that you want, right? But again, try giving some meaningful names that help you in the longer run in your interview preparation, in your interview discussions and everything. Just try giving some meaningful names in one way or the other way, right? Now let me talk about okay. One second, everybody. So now comes your applications part. What are the applications? If I talk about the applications, we have heap sort. It is a sorting algorithm that works in n log n time complexity. Then what we have applications. If I have to find some top k elements, we are going to solve all of this. If I have to find median in dynamic space, you will understand all of these applications because we're going to take them each one on one. So yeah, then we have very important algorithm, Dijkstra's algorithm, right? Then we have this Prim's algorithm. So as we go ahead, you'll see all of these algorithms taken by one, and so on. So we're able to find kth max element, then kth min element, your priority queues. They use this concept, right? So more or less everything uses this concept. Now if I have to go next, okay. So these are the questions that we'll be solving. These two I'll be taking at the end. We'll be starting with kth largest, kth smallest, maximum, sum, median. These all the questions we'll be taking one on one. It's not written in the sorted order right now. I'll be picking up any questions in the upcoming videos. You just need to remember right now one thing, that what is in this heap section, you have insertion done in log n time. This is only for one element insertion, right? And you have to delete one element. It takes again log n time. If you want to find minimum or maximum element, depending on what heap type you choose, this is done in constant time complexity, O of 1. This is what I want you to remember at this moment. And yeah, with this, we'll be solving the next questions. Next question will be taking up kth largest and kth smallest element. Since there is not much difference in this, I'll be taking both of these in the upcoming video. Thank you so much. Bye-bye.